Homework 6 starts with absolute value and inequalities, and the first few questions are about graphing things on a number line. Now, in order to graph things on a number line, the first thing you have to do is you have to draw a number line. And a number line simply means a straight line. So let's draw this as a number line. And in order to make it a number line rather than just a line, you'd put, let's say, a 0 in the middle, and then the positive numbers would be to the right, and the negative numbers would be to the left. Obviously, ideally, you'd space them evenly, but that's not really critical. Okay, so in fact, I'm going to copy this number line down here since we're going to need to use this a couple of more times for questions 2 and 3. So we'll use this number line for questions 1, 2, and 3. So let's start with question number 1. We say express the intervals set in a set notation and graph on a number line, -1 and 6. Now, when you have a parentheses over here, that's the lowest point that this series of numbers can go. And the open parentheses means it cannot actually be that number, whereas the bracket means it can actually be that number. So what this means is that the lowest in the number that this set can be is -1, and it cannot actually be -1. It can be a shade more than -1. It could be, -0.99999, and the highest it can be is actually 6. So for -1, we're going to use an open circle, and we use an open circle because it cannot actually be -1, even though that's the limit. For 6, we're going to use a closed circle, and we're going to use a closed circle because it can actually be 6. And then you draw a line in between here and here. Let me make the line a little thicker so it's a little bit easier to discern. So here is, it starts at -1, ends at 6, and the 6 is filled in, the -1 is not. Second one is very similar, starts at -2. This time this is going to be filled in because it's a bracket, and the other side is also a bracket, so we'll fill in the 5 as well. And then we'll take a line and we will draw it all the way from here to here. And if you're on a paper, you can make it a little thicker to make it a little obvious that it's the line. So that's fine. That's the easy enough answer to questions 1 and 2. Question 3 is slightly more complex, but not really much more complex. We're using the set. We're using a number line to find the set. In other words, to find what is the union, what is the intersection, what is the commonality of these two systems. So let's start with the first one, -3, 0, both parentheses. So -3 will make an open parenthesis, 0 will make another open parenthesis, and then we'll make the line in between them. Okay, and for the other one, maybe we'll use a different color to indicate, well, you can use the same color. To -1 and +2, and both of them are brackets, so both of them are going to fill in. So -1 and +2, and then we will put in a line. And if you want to know what the combination is, well, the combination you can see right away. We'll use a different color for this one. The combination is from here until here. That's in both sets. If you wanted to actually draw the combination, you can make this filled in because this area, the -1, is in both sets. Up to 0 is in both sets, blank because this one is blank, and then the line in between, and that would be your combination set. The next two problems are about solving equations and then using a number line to graph them. Now, solving an equation that is an inequality like this, rather than being an equal sign, there's an inequality, in this case a less than sign, in this case a more than sign. But either way, if you do it, you just simply solve like a regular equation. So let's say number 4, what do we got? We got 5x plus 11 smaller than 26. If it were an equal sign, then what you would do is you would simply solve for the x. So therefore, because it's a smaller than sign, you still solve for the x. Get 5x by itself by subtracting 11 from each side, and you've got 5x is smaller than 15. Divide each side by 5 to isolate the x, and you've got x is smaller than 5. To draw that on a number line, well, simply let's grab another number line from up here. In fact, let's then do another one because we'll use that for number 5 also, and we'll put it over here. And to use the number line, well, we've got x is smaller than 5. Well, okay, so let's put the 5 over here. We're going to make a circle because it cannot actually be 5. And x goes in that direction, and we'll just put an arrow at the end. Doesn't matter how long this line is, because the arrow symbolizes that it goes on forever. In other words, what this tells you is that x is less than 5, but it goes on forever in this direction. X can't be 6, x can't be 7 off this chart over here, but it can be any of these numbers. It can be 2, it can be -1, it can be -4, it can be anything to that effect. Simple enough. Let's look at the bottom one. Now this is a little bit of a more complex equation, but it's the same idea. So we've got 8x plus 3. Now with any other equation, you first open the parentheses. So we'll keep the 8x plus 3 greater than, then we distribute the 3. 3 times 2x is 6x plus 3 plus x plus 5. Let's combine whatever we can combine. We've got 8x plus 3 on this side, nothing to combine there. And on this side, we've got 6x plus 1x is 7x. 3 and 5 is plus 8. Okay. Well, now let's get all the letters to one side, all the numbers to the other. Simple enough. Subtract 7x from this side for that to cancel. So subtract 7x from this side. Subtract 3 from this side to cancel, and subtract 3 from that side. And you've got 8x minus 7x, which is plain 1x. And x minus 3 is 5. So what you have is x is greater than 5. So same thing as the other one, except the opposite direction. X cannot be 5, but it can be more than 5. And now we've done this question, and that's our answer. The next section is absolute value equations. Now, absolute value equations are just like solving regular equations, except that absolute value can have a negative value or a positive value. So, for example, if I say the absolute value of x equals 5, well, x could be -5, in which case the absolute value of -5 is +5, or x could be +5. So in order to solve a simple thing like this, you have to open up the absolute value terms. You simply have to set x equal to the negative value of this side and the positive value of this side. So x could be +5 or x could be -5. Either way, that works. So to solve these equations are the same idea. You open up the absolute value, get rid of the absolute value term by setting two possibilities. One with the positive value of the thing on the right side and the other with the negative value. So let's draw a neat little line down the middle over here. We're separating them. We've got 2x minus 1 equals +5, but also the other possibility is 2x minus 1 equals -5. We're using both possible positive and negative indicators for the thing on the other side of the equation. Let's solve each one. That's easy enough. Add 1 to each side over here. So you've got 2x equals 6. Divide each side by 2 in order to isolate the x as usual. And you've got x equals 3. On the other side, well, add 1 to each side. So you've got 2x equals -4. And again, isolate the x. So you've got x equals -2. Both of these are correct answers. If you wanted to check them, plug them back in. Let's use the 3 first. 2 times 3 is 6, minus 1 is 5. So the absolute value of 5 is in fact 5. So good. Now let's try the other side. 2 times -2 is -4, minus 1 is -5. And in fact, the absolute value of -5 is also +5, so that works as well. For number 7, we do the same thing. Now, when you're opening up the absolute value, you still have 3 times the entire expression. You've still got 3 times 2x minus 1. So on each side, you're still going to need a parentheses. So for example, on this side, you can say 3 times 2x minus 1 equals +21. And again, the reason for that is simply that you're opening up the absolute value, but it's still 3 times this entire thing. On the other side, it's also 3 times the entire thing. But this time, you're going to equal it up to -21. Okay, simple enough. Let's solve the equations. Distribute the 3 over here. 3 times 2x is 6x. Minus 3 equals +21. Isolate the 6x by adding 3 to each side to get rid of this over here. So you've got 6x equals 24. Divide each side by 6, and you've got x equals 4. That's one answer. Now let's try the other side. Distribute it in the same way. 6x minus 3 equals negative 21. Add 3 to each side, and you've got 6x equals negative 18. Divide each side by 6, and you've got x equals negative 3. Okay, for number 8, very similar, same exact thing as a matter of fact. Sorry, there's not a lot of room over here. You know what I'm going to do? I'm going to use a different color, and I'm going to solve number 8 over here. Let's do both on top of each other rather than on bottom of, rather than next to each other as we did last time. Now, the first thing you're going to want to do over here is isolate this term. Isolate the term with the absolute value. You don't want to have to worry about this plus 7 over here. That's going to make things extremely complex. So let's get rid of the plus 7 term. And the way to do that is very simpler, to subtract 7 from each side. So you've got 4 times the absolute value of 1 minus 3/4 x equals 3. Now we can set each side equal to either positive 3 or negative 3. So 4 times 1 minus, and instead of 3/4 x, we can use 3x over 4 equals 3. And on the bottom, we can use the same thing, 4 times 1 minus 3x over 4. That just makes it a little easier, equals negative 3. Now, to solve any kind of an equation, the first thing you need to do is distribute. So 4 times 1 is 4. Then 4 times negative 3x over 4, well, the 4's cancel. If this 4 is being multiplied by this whole term, so this is on the denominator, this is the numerator, you can cancel out the 4's, and you're left with a plain negative 3x. And you're left with a 3 on this side. Once you have that, isolate the 3x by subtracting 4 from each side. That gives you the 3x term, and on this side it gives you 3 minus 4, which is negative 1. Divide each side by negative 3 to isolate the x, and you've got x equals negative 1 divided by negative 3, which is positive 1/3. Of course, a negative divided by a negative is a positive. And on the bottom over here, okay, simple, same idea so far. 4 times 1 is 4. 4's cancel. So you've got minus 3x equals negative 3. Now you again subtract 4 from each side to get rid of that term, and you've got negative 3x equals negative 7 this time. And then you divide each side by negative 3, and this time you've got x equals positive 7/3. And of course, if you check it and you plug in these terms back into the original equation, both of them will work. And you're just going to have to take my word for it or try it yourself, because I'm not going to actually do it in this video. But that is how you solve absolute value equations.